When it comes to building muscle, reps between 6 and 12 are commonly used with the belief this best promotes muscle growth. This idea does somewhat stem from a pre-existing rep range continuum, also stating 1 to 5 reps are superior for strength, while 13 plus reps are superior for endurance. This continuum does have some truth to it. The evidence does support the idea strength is best trained with lower reps. Given strength is based on lifting heavy loads, training with lower reps makes sense. Likewise, the evidence does also support the idea endurance is best trained with higher reps. Given endurance is based on sustaining multiple contractions, this again makes sense. However, when it comes to the muscle growth rep range, this continuum is slightly misleading. This is simply because the current evidence does not support the idea muscle growth is best achieved exclusively in the 6 to 12 rep range. The best evidence relating to rep ranges and muscle growth comes from a 2017 meta-analysis by Schoenfeld and colleagues. For those unaware, meta-analyses are studies that combine the results of multiple scientific studies that address the same topic. Returning to the meta-analysis by Schoenfeld and colleagues, they found that both low-load and high-load training resulted in similar increases in muscle growth, provided reps were taken to muscular failure. If we were to take a look at the individual studies involved in the meta-analysis, we would see that the loads used range from 30% 1RM to 85% 1RM. This would equate to reps between 35 and 5. So why is the actual muscle growth rep range so wide? To understand this, we first must explore the concept of motor units. Motor units consist of a motor neuron and the muscle fibers they innervate. Motor units can generally be classified into 3 kinds: slow motor units, fast fatigue resistant motor units, and fast fatigable motor units. Slow motor units are small motor neurons that innervate slow twitch muscle fibers. These contract slowly and produce low forces, but are highly fatigue resistant. Fast fatigue resistant motor units are slightly larger motor neurons that innervate fast twitch oxidative fibers. These contract faster and produce greater forces. Fast fatigable motor units are larger motor neurons that innervate fast twitch glycolytic fibers. These have the fastest contraction and greatest force producing abilities, but they do fatigue quickly. Motor units are recruited in a progressive sequence. When force requirements are low, slow motor units are recruited. However, with increasing force requirements, those faster motor units are recruited to aid those slow motor units. High levels of motor unit recruitment is an important component of maximizing muscle growth, simply because this is one of the main aspects of mechanical tension. At this moment in the research, mechanical tension is the best categorized driver of muscle growth physiologically. Mechanical tension is primarily equal to the amount of force generated by a muscle. Again, this is more or less equal to motor unit recruitment. It's believed various mechanosensors, likely located within and around muscle fibers, detect mechanical tension, and subsequently initiate a signaling cascade that ultimately results in muscle growth. Based on the principles presented, you may be tempted to think heavy loads, and therefore lower reps, are required to achieve high levels of motor unit recruitment. It is true heavy weights readily recruit faster motor units, as force requirements are initially high. As the reps approach failure, further recruitment also likely occurs. With the light loads, and therefore higher reps, as force requirements are initially low, slow motor units are primarily recruited. However, as reps get closer and closer to failure, those faster motor units are recruited to help sustain force production. What this means is that both light loads and high loads are capable of achieving high levels of motor unit recruitment. This is the primary reason as to why the actual muscle growth rep range is so wide. Before we end, some of you may be wondering about the research relating to reps below 5 and reps above 35. There is evidence that reps as low as 3 can build muscle optimally. However, 3 of the studies that did find this used a greater amount of sets with the low rep range groups, so all in all, it isn't entirely clear. I should mention that it has been reported that training with heavy loads and multiple sets is more stressful on the joints and connective tissue, potentially meaning that in the long run, it's likely smarter to train with reps above 5 if the goal is to solely maximize muscle growth. As for reps above 35, the only research that gives us a fair comparison comes from Lesvikius and colleagues. They compare the use of 20% 1RM, 40% 1RM, 60% 1RM, and 80% 1RM on the bicep curl and leg press. What they found was that, as expected, loads between 40 and 80% 1RM led to similar increases in hypertrophy of the elbow flexor and vastus lateralis. However, using 20% 1RM led to significantly less hypertrophy of these muscles, roughly half that of loads between 40 and 80% 1RM. Using 20% 1RM usually means you're performing more than 60 reps per set to achieve failure. It's likely that using 20% 1RM is just too light to maximize mechanical tension. The threshold could be lower than 60 reps. Therefore, just to be sure, it's probably best to not exceed 35 reps. Additionally, outside of the lab, I'm not too sure many would willingly perform more than 35 reps for any exercise.